Hello developers! In the last part about interfaces, there was a lot of information to take in, especially for an introduction tutorial. Now we will focus on some more basic stuff. In this part, we will cover instructions, which are used to control the flow of our programs. We will go through 4 different instructions to control flow. The first one is if-else statements. Then we will continue to case switches. Then go on with for loops. And finish with while loops. We will end this part by finishing the implementation of the persistent event logging that we started in the previous part, which we will do by using our newly acquired knowledge. This is going to be fun, and let's get started. We will start with conditional statements. Very often when you write code, you want to perform different actions for different decisions. You can use conditional statements in your code to do this. Conditional statements are achieved by either the if statements or case switches. Use if to specify a block of code to be executed, if a specified condition is true. An example of this is shown here. We simply check for a condition, and if this condition evaluates to true, we execute the code within the if block of code. If the condition evaluates to true, everything between if and if is executed. The condition can be any Boolean expression, such as checking if a bool is true, or checking whether an integer is larger than a value, or even checking whether a string has a certain length. Use else to specify a block of code to be executed if the same condition is false. By adding the else keyword to the above example, we simply provide a path of execution if the evaluation is false. Use else if to specify a new condition to test if the first condition is false. By adding the else if keyword, as shown in the example here, we simply provide additional paths of execution. You can have as many else ifs as you want. Use case to specify many alternative blocks of code to be executed. We will not discuss this instruction. The case statement is used to perform different actions based on a condition variable. The value of the variable is compared with the value of each case. In the above example, the variable is checked against the value x, y, or z. If there is a match, the associated block of code is executed. In the above example, it's the comment block of code that is executed for every constant variable x, y, and z. If there is no match, the else code block is executed. The else statement is optional. Looking at the above example, the flow of execution will look like follows. First, we enter the case statement by checking the condition variable. This variable could, for example, be of the type word or int. You can't, however, use all data types. For example, strings are not supported. For that, you would need to use an if and else if instruction. Next, we check whether the variable has the constant value x. So if the variable was an int, this could be a check of any number, say 42. If the value of the variable equals x, then we execute the code block of x. If not, we check if the variable equals the value y. If it does, we execute the code block of y. If not, we check the next constant value, in this case z. Again, if the variable we are checking matches the value z, we execute the code block of z. If not, we execute the default code, which is everything in the else instruction. Note that instead of case instructions, you can also use the if and else if instructions to achieve the same functionality. Although for cases where you want to test for many values of a variable, the case switch is generally preferred. For loops can execute a block of code a number of times. They are handy when you want to run the same code over and over again, each time with a different value. This is often the case when working with arrays. Let's assume you are calculating the sum value of an array of size 5. Without a for loop, it could look like something like this example. Just imagine how this would look like if we had an array with a size of 100. Instead, you could write a for loop. In the for loop, we use a variable in here called nCounter that is assigned a value at the start, in this case the value 1. The for loop is executed up until it reaches the value 5. The for loop automatically increments the variable n counter by 1 at the end of the for loop. The step size defined by using the keyword by is optional, and if it's not defined, it will implicitly be 1. The while loop loops through a block of code as long as a specified condition is true. If we take the same example as in the previous slide in where we want to sum all the elements of an array, the equivalent while loop would look like this. The while loop consists of a test expression. This test expression could be anything. For example, if a number is lower than another number, if a string equals another string, or if two booleans are true, and so forth. As long as the expression is true, the while loop will continue to execute. In this case, as long as n counter is less than 6, it will execute everything in the while loop. As soon as n counter will have the value 6, the expression will no longer be true, and we will exit the while loop. Okay, it's time to go back to a little bit of programming, and we will continue where we left off in the last part. So by implementing this function block, by actually implementing the function block that implements this interface. And again, if we go back, remember that this interface only had one method that was called a store event, which basically just passes an event that is to be stored persistently. But now we're going to actually implement this to persistent storage. And I've been thinking about this a little bit, and I think XML is a little cumbersome to use. So I thought we're going to make it a little bit easier for us and implement a CSV logger instead. So comma separated value file. So we'll just simply write stuff into a CSV file. So I'll rename this to CSV persistent event storage. I mean, it's still implemented the same interface. It's the only difference is instead of storing the data in an XML file, we're going to store the data into a CSV file instead. We will implement the function block fb_csv persistent event storage that implements the interface I_persistent event storage that we defined in the previous part of this tutorial. The fb_csv persistent event storage function block will write our events into a comma-separated value file. To do this, we need to define a state machine that consists of several steps to achieve our goal. State machines are very common in the world of PLC programming, and you will come across them many times. First, we need to think about what this function block is supposed to do and what steps we need to implement. Our first step is to open the file that we want to write to. This is accomplished using the built-in function block fb_fileopen. This will either open an existing file, or if the file does not exist, create it and open it. The second step in the state machine is to wait until the function block receives an event from outside. The event will be added by a call of a function block that has a reference to the interface I_persist event storage. This function block will call the store event method, which will provide all the necessary data for our CSV writer function block to continue to the next step. In the third step, we will write the actual event data to the file. Every time we get a new event, we will create a new line in the file for that event. Writing a line of text is accomplished using the fb_fileputs function block. In the last step, we could close the file using the function block fb_fileclose. This is, however, unnecessary to do, as we can just keep the file open all the time. Because we know that we will want to write more events, we will save some time and resources by not having to open and close the file every time an event is added. Instead, as soon as we are finished with writing an event to file, we will just immediately go back to waiting for a new event. So to actually implement this, we don't need any, I don't think we need any inputs or outputs. To implement this function block, we need a couple of Beckhoff functions. And the first one is that we need to be able to open a file. Okay, so to do that, I just generally Google file open TwinCAT. There we have the function block fb_fileopen. So what we're going to do now is to use a state machine to be able to store this CSV entries. And a state machine is something that you'll come across quite often in the world of PLCs. And to do this, we're gonna create an enumeration. The enumeration will define the state machine. PLC programmers, and this is generally most PLC programmers I've seen, they like to define state machine like in this way. You have a state, that's just an integer, and then you just say case and state off, and then you just have these numbers 10, and then some code here, and then 20, that's another step. Then there's more code, 30, even more code, and etc. I see this quite often, not just by PLC programmers, but also if you look at all the Beckhoff examples, you see this quite often. And I would advise you not to do this. And I think Beckhoff it's quite bad that they're using this as example code, because then it's just new PLC developers see this and they think this is how I should do it as well. This actually is, the reason this is bad is because this is just magic numbers. 10 doesn't say anything about what's happening here. 20 doesn't say anything either. It's just these magic numbers. And this is just not these numbers. Any magic numbers in your code you should try to avoid. You should try to make your code describe as much as possible. Because again, most of the time that you will develop code, absolutely the vast majority of the time will not be new code. It will be understanding existing code. So just really try to make your best to make the developer after you, or even yourself in 1 year from now, understand this a little bit better. So just spend a little more time now, write clean and pretty code, and it will pay off in the future. Everyone will benefit, not just you, but your employer, the next person after you, everyone will be happy. So instead of using this, we're going to use something called local enumerations. And it's basically an enumeration that's only visible in this particular function block. So it has very local scope. As I talked about enumerations previously in another part of this tutorial, then enumerations are visible all over the whole project. While here they're only local. So we're going to call this enumeration write state, and then we can define all the steps here. We have several steps. First of all, we're going to open the file. So that's the absolute first step. We need a file to write these CSV, comma separated values, because what we're going to do is that we're going to write a comma separated value, a new line for every entry, for every event. So every time you have a new event, then we will get a new line in this file. Once the file is open, we don't want to write anything unless we have something to write. So we need a state that just basically waits for something to happen. That is, we needs a state that just waits for an event to be triggered, an event to be included. And the event is included by this store event method. So we need a waiting state, so wait for event. Then we need, what do we need? We need to have an actual write event. That's once we have an event, we go from here to this one. And then we also, once we have written the event, we need to close the file as well. This is actually optional because we can just keep the file open all the time. But we'll add this for now. We might want to use it in the future. I mean, this is optional because once we have an event written, we can just wait for the next one. So the first step is we're going to use the case switch over this enumeration instead. Now, I like these enumerations because they're only global into this function block and they're not going to pollute the namespace. They're not going to be visible from anywhere else. And we don't need them to be visible for anywhere else because all of this functionality is specific for the CSV persistent event storage function block. If we had a SQL database function block that implements this, we wouldn't need to open a file. This we might need, but we don't need file close and file open for sure. It's going to be a different set of states. So I like this local enumerations, and this is something I have from the time from C++ and Java. We want to keep it as local as possible and not just pollute your stuff all over. We do that. And now we're going to define this. We're going to do file open. Then we're going to do wait for event. Then we're going to write the event. Then we're going to close the file eventually. We'll see about that. Okay. So to file open, we're going to use this function block fb file open. And this is a function block. Actually, this is the TwinCAT 2 documentation. So let's go back. That's the thing. I mean, you probably already noticed this, but when you Google something, the first hit is always the TwinCAT 2 alternative for some reason. Probably because TwinCAT 2 has been around much longer. I just automatically, generally just click on the second hit. Then you usually get the TwinCAT 3 stuff. So we're going to use this function block. This function block describes basically everything we need. The function block creates a new file or opens an existing file for editing, and that's what we need. So we're going to use this guy. And this is available in the TC2 system namespace. So we instantiate a FB file open. Just call it FB file open. And we can already assign some of these parameters. All of them have all of these input parameters. Some of them have default values, and some of them are quite interesting. We need to look a little closer to them. The first one is this SNet ID. Default, we want to open the file locally on the PLC, so we'll just leave this as default. If you don't put any SNet ID, you will use the local PLC, that is the PC that we're running this on. The path name is interesting because this is the path to the file. So this one we can set, and this is possible by, you can assign values like default input values like this, and then we can just set path name to see events.log, and then end mode describes how the file should be opened. So we don't want to just read to it, we want to be able to write and append. So you have these modes that you need to, and the way you do it is you operate them with an OR operation. So if you want to write, you do and append, you do an OR between these guys. And we want to open them not as a binary file, but a text file. So what we're going to do is we're going to use this end mode. And this we only need to do once. That's why I always do this way. Everything that's constant and that I don't change, I always do it in the declaration. Then we don't need to pollute the actual implementation with this stuff. So let's do it this way. Or I should mention that the reason that we can access this function block is because we have a reference to the TC2 system library, which is where this guy is important. It's going to get very important when we develop our own libraries, which we will get back to in a future episode of this tutorial. We want to OR it with this guy, and we want to OR it with this guy as well. Okay. I think that's it. And what parameters do we have more? We have execute will trigger later, timeout, we can leave it at the default timeout. The path, this we can leave at this path generic, leave it at default, and that's it. Okay, so we need this function block, and then wait for event, write event. To do the actual file writing, we can just check file write TwinCAT. I don't think we're gonna use this guy. There is, oh no, I did the mistake with TwinCAT 2 again. I never learn all these years, and I still always end up with, TwinCAT 2. File puts, this I recognize. This is the function block we want to use. So TwinCAT file puts TwinCAT 3 maybe. Okay, there we go, file puts. The function block writes strings into a file. That sounds good, right? We want to write a single line. The string is written to the file up to the null termination, but without the null character. The file must have been opened in text mode, and we have opened it in text mode. That's why we use the FB file open. So this guy is what we want. So we're gonna instantiate that function block as well. And we're gonna assign some default parameters. SNet ID, we leave it at default. That's gonna be localhost. Hfile, that's a handle to the file that we have opened. And the handle to the file that we have opened will be provided as an output from the file open. So if you look at the file open, you'll see that one of the outputs is this handle file. So it's like a memory location somewhere in the computer that provides you a handle to this file. So this we don't want to do during declaration. This we want to do during runtime, because we don't have it during the declaration. We will get the handle during runtime. So S line is the string to be written, So this we don't have either, because this will be our event. Be execute we don't have now, and timeout we can leave at default. So we'll leave everything at default, which means we'll just do like this. We're gonna start with opening the file. This we do by calling this function block. And when we do that, every time you have a function block that has this be execute flag, you need to start this function block. You need to setting this parameter in with a rising trigger. So if you set it to true, this function block will start to execute. This is the way I always have a little problem thinking about it, but the way you have to think about it is a rising edge will start it, and then the function block has to be continuously executed, because what's happening now is that what you're basically requesting is a command to Windows to open this file, because we're still dependent on Windows, because all this file handling is done in Windows. And this is not real time. So we need to have this asynchronous communication between TwinCAT and Windows. So you set a rising edge trigger to start to tell Windows, hey Windows, I want you to open this file. And then you need to continuously call it until this file is actually opened. I mean, this might take 1 millisecond, so it might even happen in the same cycle as this call to this function block, but it might take 10 seconds. We don't know. That's why we need to continuously call this file open until the output be busy is not true, so it's not busy anymore and we don't have any errors. What we need to do is to split this file open into 2 steps. It's one step that's file open trigger the function block, and then file open just wait until the file is actually opened. And again, you're gonna meet this type of stuff all the time when you have asynchronous communication. You know, if you have some motion function block, if you're sending, it doesn't have to be Windows stuff like this non-real-time stuff. It can also be that you're sending a command to a robot, please move there, please move to this position. Of course, this is gonna happen independently of the PLC cycle time. So that might take 1 second, it might take minutes. If you have a filter wheel or something rotating, it might take many minutes before it completes. So then you need a state machine where you say, please start now, and then you just wait for it to actually finish. So we're gonna split this file open into a trigger, we can call it trigger, and then that's actually starting this file opening, and then file open. That's the actual file open, where we'll wait for this file to be open. And it's going to be the same thing you'll see later with the write event and file calls, but we started this one. So this will be file open trigger, and then we're going to need a file open. So in this one, we just trigger the function block by be execute true. That sets a rising edge trigger to this to execute this function block. And then we just need to wait until it has actually opened the file. And we do that by file open be execute false. So we don't need to send this true every cycle. It's enough to do it in 1 cycle. And then we need to wait for the result. What we want to do now is to check whether we basically got an error or not, whether it was successful or not. So, and the way you do this is if we go back to, I close this FBF5 open, sorry, is by these outputs. So we want to check whether it's busy or not. If it's not busy and doesn't have an error, then everything is fine. If it's busy or has an error, then we should wait. So first of all, we want to check if this guy has an error. Because if it has an error, then that can be many reasons for why it has an error. It might be that this file doesn't exist, or maybe we don't have access to this hard drive, or many reasons. Then we need to have some error handling. And right now I'm not going to make some very advanced error handling. We're actually going to add an error step. And if we end up in the error step, we're not going to do anything. In a program, in a full program, you of course want to have some sort of error handling, either notify the operator or have a red blinking light, or handle it, maybe do a retry. Right now, we're not going to do nothing. We're just going to log in here and see if we actually end up here. Okay, so this is what we're going to do. And if we end up there, then we are going to that step. So we say that then the write state is error. And then we go to error. Oh, I forgot, by the way, that once we have triggered this one, we need to go to the next step. So we need to set that write state is equal to file open. Then, and next check is else if FB file open is not busy. So if we have an error, we'll go here, but if we don't have an error, then we need to check if it's not busy. If it's not busy, it means that it was hopefully successful. So we actually also need to check whether we actually have received a handle to the file. And this we do by making sure that the handle, and that the handle here, the handle to the file is just an unsigned integer, that this guy is not equals to 0. Then we know everything is fine. Then we can wait for the event. This is the situation we want to end up in. Then we want to wait for an event. Okay? If we are waiting for an event, we don't do anything. What we're going to do instead is that we're going to have some code that puts us out of this once we have received an event. And what we're going to do is do it when someone calls the store event here. Okay, so in the last part we ended up with just creating this stub method. This method is part of the interface, and here is where we're actually going to do the code. So what we're going to do is to check that if our current write state is wait for event is equal to wait for event, then we're going to put the write state to write event. So that's what we do. If we receive an event and we are waiting for one, then we just want to put the state machine into please write this event. And I should notice something here. I already saw this coming. The problem with this is, of course, what if two different function blocks? What if we get two events at the same time and one event hasn't finished writing? With this implementation, we can only write one event at a time. And if I would to do this properly, I mean, if I would to do this for a customer or for any real machine, I would create some sort of circular buffer. So you can just add as many events as you want up to the size of a buffer, and then you would have the function block just go through this buffer. In this one, we're going to keep it simple because I have a feeling it's going to be complicated enough. So we can only have one event at a time. But of course, what this means, if we have an event that's being written and someone else calls store event at the same time, then we're not going to be here, and then we're going to lose the event. And this, of course, in a real world scenario, we would have to have code to handle this. Yeah. But it's not enough. We actually need to store this somewhere so that the function block, this guy, can process it. So I'm just going to call it stEvent written to file, and that's an stEvent. And when we receive the stEvent, we're gonna store it. And that means that if this is called, then we will automatically go to write event. And then we're down here. Okay, fun. Write event, then we're gonna use this FB file puts. That's where we actually gonna write the event. There's two things we need to do here, by the way, I realize. The event is just a structure right now. So everything is just in this memory location of the PLC, but we want to put it down as a string, like just a long line of text data. But we'll start with just calling FB file puts and trigger it with b execute equals true. So we're gonna have to do it the same way as we did with file open trigger. So we need to have a write event trigger, and we need to have a write event where we actually just wait for the event to be actually written, because it's the same as with opening a file. Writing to a file, it's done in Windows, so it's asynchronous. It can take 1 millisecond, but it can take several seconds for the file to be actually written. You have no control whatsoever when stuff is done in Windows, because it's not deterministic. Windows can decide to do something completely different. That's why we need to have this communication, this messaging, or whatever you want to call it. I'm just going to create this. I'm going to rename to file event trigger, and then we need to have a file event, write event, sorry. Notice that it's quite nice with this code when you can just look at the code and then it's obvious what's happening in each and one of these states instead of having a number. So again, you're going to make a lot of people happy by structuring your code in this way. So I just mentioned that if we're going to write the data, then we need to convert this structure into some string that we can just write, because file puts doesn't want a structure. What it wants is just a string of type tmax string. This tmax string is just an alias. We haven't talked about alias, but an alias is just another name for something, and tmax string is just a string of size 255. So it means we can at max write a string that's not bigger than 255 characters. We need to actually convert that, and what we're going to do is that we're going to create a helper method for this. So we're going to create a method that takes the structure of st event and converts it into our CSV string, so with commas and everything. So we're going to add a method, and I don't know what we can call it. The naming, that's always the problem. What should I name the method? Create CSV string, maybe. And it's returning tmax string, because that's what the file puts wanted. And it can be private, because no one else outside of this function block needs to have access to this method. So what this method is going to do, it's going to return a tmax string, and as input, it's going to have an st event, or reference to an st event. First of all, we need to create a temporary variable to work with. And for that, we're gonna use temp string. That's also a tmax string. This is just so we can work with it. And this event consists of the event type, the event severity, and some other data. So we have to convert all of these into strings. So first of all, the temp string is gonna be the event type. But to convert this, there's actually a trick. You can use something called an attribute for toString. So you can ask TwinCAT to automatically convert any event into a string. And I don't remember how you do that, but enumeration to string. Enumeration to string, TwinCAT. You see from 4024, so this is quite recent. You just add this attribute to string. And what you can do then is to add, just write toString, st event, event type. So what will happen now is that if, for example, the event is message, then we're just going to get a string that's where it's written message. It's super convenient. So you don't have to create any special conversion functions from an enumeration to a string. The TwinCAT will do this automatically for you if you add this attribute, this pragma. So we start with that. And then the next thing we do is we add a comma to this string. And what you do that is you do it by concatenating. And for that, there's a very convenient function. I'll get to this in the next part of this tutorial, so I'm just going to briefly mention this. It provides two strings, and out you get another string. So if you concatenate, it's a tricky English word, Susie and Willie, you will get Susie, Willie. And what we want to concatenate is we want to add this enumeration with a comma. So we add concat. String 1 is the event. String 2 is just a simple comma. And this is how we're going to create our string. We're going to add field by field by field, and between every field we're going to have a comma. Right? So we just continue. Temp string is concat of temp string. and the next one is this event severity. And this one is a TwinCAT type, which doesn't have the string attribute. So we just simply store the, this is implicitly, this is an integer. If the type is not declared for enumeration, like it's not here, then it's implicitly an integer. So we just store the integer value. So we can just do toString this guy. We're not going to get the nice and convenient name like these guys. We're just going to get the number, but that's fine. toString. Why doesn't that? Ah, yeah, of course. It's the SD event. So again, this temporary string, we just use it to build up the string field by field. So it just grows and grows and grows until we get the complete string with all the data that we're gonna write into this file. So temp string, now we have to add another comma. So we can just take this guy. Now we have the event type, the event severity with a comma in between, another comma. Now we are gonna build, we're gonna add data to the temp string, and now we want it to be the next stuff, and that's the event identity. Then it's toString. We're just converting the unsigned double integer into a string, and event identity. And then we want another comma after that. So now we have the event type, comma, the event severity, comma, the event identity, comma. Then we want the event text, and you can already see a thing here. This is another string of 255, and this returns a string of 255. So this could potentially be something unfortunate. If you had an event text that was very big, we should handle it. We should try to shorten it. We're not going to do anything fancy right now, but as a warning, you should be aware of this, that this is an additional possibility of failure. A lot of the stuff, I generally never write code like this. I do something that's called test-driven development. We will get back to it in the advanced part of this tutorial. And then you generally take care of all these very fuzzy use cases, these dangerous use cases, before you actually write the code. It just generally gives much better architecture. I just have this in the back of my head all the time that, oh, this is scary. Okay, so temp string. We concatenate it with the event text, and this we don't need to do on toString too because it is already a string. And another comma. Oops. This, why does, oh, yeah. Like this. And then we only have the date and time. So that's the event date and time, which is the DT timestamp. And then we want to do a toString because that's of date and time type. I don't know exactly how the string will look like when you convert a date and time into a string, but probably something that's more or less human readable. And the temp string is fully built up now. Now we have missed one thing. What we want to add is a new line. So once we added a whole line of data, we also want to make sure to add a new line characters so that we get a new line for the next event. Otherwise, all of these strings would just create a huge, long, infinitely long line in the file. And to do this, we can look for special characters, TwinCAT, string constants. Half of the time you Google, that's what you do. That's maybe not so much in TwinCAT, but for sure if you're a C++ developer or Java, I probably spend most of my time on Stack Overflow. At least I'm being honest about it. This is some string constants. So basically these are just some constants that you can use when you want to do something special. So here we want a new line, then we need this special character $n. And if you're a C developer, you probably recognize this, although it uses a \n instead. So we don't need a comma, we just need this special character. So we need to add it to our temporary string. And we need to add it, and it's this like that. So after the timestamp, we'll just get a new line, which means that the next event will start from a new line. And then finally, we can't forget this method needs to return this, and the return of this method is going to be the temp string. So now we have a nice and neat helper method. We could even put this out externally to a separate function, but I think it kind of makes sense to keep it here. I wouldn't put it in a separate function because this is specific for CSV files, right? This is because we're actually using comma-separated value file, right? And here we have the comma. So I would just keep this helper method in this function block because it just kind of keep them together. Now we go back to the file event trigger, and what we want to provide is we want to create this string. We can just create a CSV string. That's a T. And this CSV string we will create through this helper method, create CSV string, and the SD event is the SD event written to file that was provided in wait for event, right? Because when we did the store event, we said that whatever event comes in here, store it in here. So this is the event we want to write. So we want the SD event to be SD event written to file. So this helper method will convert this memory, so this structure, into a nice long string. And this is the string that we want to provide to this function block. This is the S line. So S line is equal to CSV string. And now we just need to wait for it to actually be written. So what we're going to do is we're going to update the state machine to write event. Actually, I forgot one thing. Because what I added these states, write event trigger. When we add an event, we want this one to be write event trigger, because we want it to start with write event trigger and then go to write event. Now we just have to call the file puts until there's either an error or until it's done. So we just call bExecute equals to false. Let me just double check that I haven't forgotten something. No, the line and execute. So that's everything. Now we're going to do it exactly the same way as the file open, that we just check whether we have an error. So first we check if fb file puts error. There could be many reasons anyway for an error. Then we want to put the state machine into error, just as with opening the file, so we get here. Otherwise, if this is not busy, because the busy flag will be high as long as we're actually writing to this file. But if we're not busy, then everything is fine. And I'm going to be a little brave now and actually not go to file close. I'm not going to use this. I'm just going to go back immediately into wait for event. So we write our line and then we go back to wait for event. So we're going to write state. So we wait for the next event. Because we actually don't need to close the file. I don't see any reason right now why we would need it. I might change my mind very soon, but right now I can't see a reason for it. Because I mean, we just want to wait for the next event, and it doesn't make sense to open and close the file all the time. We can just open it once when TwinCAT starts, and then we can leave it open. And that's about it for this function block. I think we're in a state where we can try it. What we need to do now is in our main method, the main program, we need to create an instance of this. And now we're actually, we said we're not going to use XML, we're going to use CSV persistent event storage. And we provide this through dependency injection into the event logger. So the event logger, as I said in the previous part, through dependency injection has a reference to an interface, persistent event storage. And that's exactly what we provide. And in this case, we provide it to a CSV writer, but again, it could be anything else. It could be a database logger, an SQL logger, or actually an XML logger, or JSON logger, or there's so many formats that I just get tired of them, to be honest, because everyone wants to come up with their own standard. I sometimes just think that I should come up with my own standard and force it on everyone and become famous. No. I can remove some old code from here. And now what we also need to do is to actually call this function block, right? Because the actual writing of the data is done through calling this function block. So that's what we do. We call it. By calling it, we know that all of this is called cyclically every PLC cycle. And then the state machine takes care for everything else for us. Really neat. Let's compile it. Build, rebuild solution. Okay, it worked. You know, it's quite funny. If it works, I mean, if it doesn't work, then I always wonder, why doesn't it work? And when it works, then I wonder, why does it work? It's just like, I can never get happy. Oh, it's not easy to be a developer. Let's activate the configuration. So what we're going to do now, we created our test event, and if we set this boolean online to true, then we're going to trigger an add event. And again, if we go back to the previous part, the add event will add it into our event buffer where we keep all our events, and then we will actually call the interface store event, which in turn will call the actual implementation, CSV persistent storage, which is this guy. So this is quite modular. We can replace this with anything else, and we can even replace it during runtime. I mean, we could have many instances here of different type of loggers that we can change during runtime. And there's many other advantages in doing it this way as well that we're going to get back to in future parts of this tutorial. So anyway, we can run this now and see whether we're actually going to get something. And okay, and the file was supposed to be something with event logs here, which we don't have yet. So, oh yeah, okay, the program isn't running. So what we can do is that we can log in and we can check this. Let's run it. Okay, we immediately got the error. So, oh, there's an error with file open. And why do we have an error? Error ID 1803. So let's check what that means. Oh, this is in hexadecimal, and this is another trick I can show you now. When you have this is in decimal, you can right click, display mode, hexadecimal. 70B. Okay, we don't have that here. Okay, I see that I've actually opened the file in a wrong way. I not allowed the, if I'm going to open it with mode text, I can open it with mode append or open mode text, but not mode write and append and write. So the reason I couldn't open the file is because I only need to open it with this mode append and mode text, and not mode write. I guess that is because mode append implicitly means that we're going to do a write as well. So let's try again. I mean, this is the fun part with developing, right? You get an error and you look into it, and why do I get an error? Yeah, look, wait for event. So that's fantastic. And this is the nice local enumerations. They're really magical, I must say. I love these guys. And what we're going to do now is that we're going to do a boolean, this set to true, and then we will add an event with event type alarm, event severity error, some identity, and some event text. So let's write that. and we got into error. So it means that the file puts had an error for some reason. Let's check why. 703. Ah, I know why. I missed a very, very important thing. The file puts doesn't have any reference to a file, right? Because the reference to a file is in FB file open. That's the file handle. We didn't provide it. We need to provide it here. So H file is the output from FB file open H file. That's how you link the file puts together with the file open. So we need to provide that. Otherwise, I mean, file puts doesn't know which file should I write to. It got very confused and sad. Okay, wait for event. Let's go back. Right. Ah, and we got back to wait for event. That means that and check the file puts, and there's no error, there's no busy, nothing, and we're back at wait for event because we set once the event has been written, when the file puts was not busy anymore, then we say go back to wait for event. So we should have the look here, but no event. I have a slight feeling about this. We might have to close the file, but what we can do meanwhile is that we can just turn off TwinCAT. That should implicitly close the file. So we shut down the TwinCAT kernel, we put it into config mode, see if this, yep, that's what happens. So you actually need to close the file for the line to be written to the file for some reason, but here we got it. This is the data we put. We said that it was an alarm. The number 3 here, that refers to, let's see, that refers to the TC event severity error. We can double check. Error is 3. And then this is just our event identity that we also set somewhere here. Here. This is the message, this is a scary event, and this is the date and timestamp. It's working, but we should also close the file. So what we're gonna do is that we're gonna instantiate file close. I guess that's at least what it's called. This is probably TwinCAT 2. Yeah. TwinCAT 3. We leave this at default. We have to trigger it, and we have to provide which file, so handle to the file that we want to, which we have from file open. So we need to we need a file close, and just as with the other file open and file write, we need file close trigger, where we trigger the function block, and then a file close where we check that it's actually closed. So file close trigger and file close. When we have written the event, we tell it to close the file, and that's what we're gonna do now. And we need to instantiate FB file close, FB file close. And then we call it FB file close. We set our rising edge trigger, execute true. We can also provide which file we want to close, because that's the handle here. Each file is the handle is from FB file open handle. Yeah, and that's it. And then we set the write state to file close, where we verify that the file is actually closed. Then we execute false. This is the same as with the open and file write. And then we check if FB file close. First we check for errors. If the file couldn't be closed for some reason, we should have error handling. We put it into error. Else, no, not else, but else if FB file close is not busy. So not busy, then everything is fine. So we wait until the file close function block is not busy anymore, which means if it's not busy, it has successfully closed the file. And now is the thing. If the file is closed, then we need to go back and open it again. And that, which basically means we'll start all the way from the beginning. So if it's successfully been closed, then we open it again. There might be another way to do it, because I'm actually not entirely happy with TwinCAT not writing to the file immediately. There's probably a reason for it. I can't come up with it now, but we just do it this way. We can always ask the Beckhoff support or Stack Overflow if anyone has a good suggestion. If anyone has a suggestion, by the way, and knows this stuff, you're welcome to write a comment in below. Then we go back to file open trigger once the file is closed. And then it should restart, it will open the file, and it will wait for the next event. And again, I just want to point out again that if during this stage where we write the event or we close the file, if we would get a new event by the call to store event, we wouldn't write the event because we're not in the wait for event state. And that's really bad, of course, because then we lose the event. So I would encourage you, if you want to do some exercises, to add a buffer to here, so we can have several events at the same time that are written. So let's see if this makes any difference. I'm gonna, just for fun, I'm gonna clear this. Aha, okay, I can't. Okay. Let's see what happens now. Run. We will write this. Let's see if it, yeah, it's back to wait for event, but we still only, yeah, now it works. We got the line immediately. You see, we got the second line immediately. I will just try again to trigger this guy, then we're gonna add an event. I trigger it, jump. Maybe I have to reopen the file. Oh, maybe it was because I had the file opened. With, I'll just try again. Wait for event. Yeah, just to be absolutely sure, let's change this to message, this to verbose, the event identity to, oh, this is 42, so 43. Hello world. Let's write that. And then let's write a new event. And let's open the file. This is confusing. Maybe I was a little too quick. Okay, now it says that it has written the hello. Okay, there we go. Yeah, so it seems to be working. We simply have to close the file in between every time. And that's fine, but I would say that this is working right now. And yeah, and that's basically it for the CSV persistent event storage function. And the good thing here is that we have been able to exercise the usage of state machines. And you're going to get back to state machines a lot in the future. I think this was a good way to exercise them. And again, I just want to remind you to try to use this local enumerations and not just try to keep the code as clean as you can. Yeah. That was fun. Unfortunately, all fun things come to an end, as this is the end of this part. In the next part, we will look into some of the powerful features that every IEC 61131-3 compliant PLC has. See you in the next video.